Let me start with a simple question. Why does it feel better to walk barefoot on dirt than on concrete? Not better in some poetic or emotional sense. I mean physically, subtly, quietly, almost like your body recognizes something your thinking mind hasn't yet put into words. This is the kind of question people usually ignore because it seems too small to matter. But small questions are often dangerous in science. They look simple, so we answer them too quickly. And when we answer too quickly, we stop looking. So instead of answering, let's slow down and actually look at what's happening. Picture yourself standing barefoot. Under one foot is natural ground, dirt, maybe a little uneven, maybe slightly soft, maybe cool. Under the other foot is concrete, flat, rigid, and predictable. At first, the difference feels obvious. One is soft, the other is hard. But that explanation is not wrong. It's just incomplete. Because your body does not actually sense softness or hardness directly. Those are labels your brain creates after the fact. What your body really detects are patterns of pressure, tiny deformations, vibrations, and changes over time. Your foot is not just a passive object touching the ground. It's a measuring device, an incredibly sensitive one, constantly collecting information. Every time you take a step, something like a small experiment happens. Your foot presses down. The ground responds. Forces travel upward through your bones, your muscles, your joints. At the same time, receptors in your skin send signals to your brain about what just happened. And all of this occurs so quickly that you never notice it consciously. Now here's the interesting part. Two surfaces can feel different even if you apply the same force to them. Let's imagine pressing your hand onto a cushion and then onto a stone. You use the same effort, but the experience is completely different. The cushion gives way, the stone resists, but more importantly, the timing of the response is different. The cushion changes shape gradually, the stone responds almost instantly. Your nervous system is extremely sensitive to this timing. It can detect differences on the scale of milliseconds, far faster than you can consciously think. So when you step on dirt, your foot is not just feeling that it is softer. It is experiencing a slower, more distributed response. The ground shifts, compresses, rearranges itself under you. Concrete, on the other hand, behaves almost like a mirror for force. You push down, and it pushes back, immediately and directly. This difference may seem small, but your body is built to notice small differences. In fact, it depends on them. Because walking is not just falling forward and catching yourself. It is a continuous process of adjustment. Tiny corrections happening step after step, guided by the information coming from your feet. If that information changes, even slightly, your entire movement pattern changes with it. And here's where things begin to get interesting. Because now the question is no longer just which surface is softer. The real question becomes, what kind of conversation is happening between your body and the ground beneath you? And more importantly, what happens when that conversation changes? Now let's take that idea a little further, because something important is hiding inside it. Every time your foot touches the ground, energy is involved. Not in an abstract textbook way, but in a very physical, unavoidable sense. Your body has mass, you are moving, and when your foot comes down, that motion has to go somewhere. Energy does not disappear. It cannot simply vanish. It must be transferred, transformed, or absorbed. So imagine taking a step. Your foot moves downward and forward, and then it meets the ground. At that exact moment, your motion is interrupted. The ground pushes back on you, and this interaction determines what happens next. Now here is the key question. Where does that energy go? If you step onto concrete, the answer is surprisingly simple. Concrete is extremely rigid. It does not compress in any noticeable way under your body weight. So when your foot hits it, there is very little give. The energy you bring into that step cannot be absorbed by the ground, so most of it is redirected, sent back into your body. Not all at once in a dramatic way, but distributed through your heel, your ankle, your knee, and upward through your skeleton. It's like bouncing a ball on a hard floor. The harder the surface, the more energy comes back. Now compare that to dirt. Dirt is not a single solid object. It is a loose collection of particles, grains, small pockets of air, bits of organic matter. When you step on it, those particles shift. They slide past each other, compress slightly, and rearrange their positions. All of that motion takes energy. So instead of reflecting energy back into your body, the ground is doing work. It is absorbing part of the energy from your step and dissipating it in many small ways. Through friction between particles, tiny movements, even slight heating at a microscopic level. You can think of it like catching a ball. If you hold your hand still and let the ball hit it, the impact feels sharp. But if you move your hand backward as you catch it, you spread the force over time. The same total energy is involved, but the experience is completely different. Dirt moves its hand back, in a sense. Concrete does not. Now here is where things become subtle. The difference is not just about how much energy is absorbed, but how quickly it is absorbed. Concrete responds almost instantly. The force rises sharply and then drops off. Dirt stretches that interaction over a slightly longer time. The peak force is lower, even if the total energy is similar, and your body is extremely sensitive to peak forces. A small change in how quickly a force is applied can change how your muscles activate, how your joints align, and how your nervous system interprets the step. This is why two surfaces that seem only slightly different can produce very different experiences over time. But here's the part we don't fully understand. We can describe these physical processes. We can measure force, pressure, deformation. But connecting these measurements to long-term effects in the human body is much harder. How much energy reflection is too much? At what point does it matter? How does the body adapt over years or decades? These are not simple questions, because your body is not a passive structure. It adapts, it compensates, it learns. So when you walk on concrete, your body does not just take the hit, it changes how it moves to deal with it. And that raises a deeper question. Are you experiencing the surface itself or your body's adaptation to it? Now consider something even more subtle, something that hides in plain sight. Your body is not just reacting to the ground, it is expecting something from it. That expectation did not come from conscious thought. You were not born and then logically concluded how the ground should behave. Instead, your body carries a kind of built-in assumption, shaped over a very long time. For most of human history, the ground was not flat. It was irregular, slightly soft in places, firm in others, sometimes shifting, sometimes stable. No two steps were exactly the same. So your body evolved in an environment where variability was the rule, not the exception. Now imagine what that means for the way you move. When you walk on uneven dirt, your muscles are constantly making tiny adjustments. Your ankle shifts slightly to one side. Your toes grip just a bit more. Your balance system makes rapid corrections that you never consciously notice. Each step is a small negotiation with the ground, and because the ground is unpredictable, your body stays alert. Not in a dramatic, tense way, but in a quiet, continuous readiness. Your muscles don't just activate, they fine-tune themselves in response to subtle differences. This constant variation is not noise, it is information. Now compare that to concrete. Concrete is almost perfectly uniform. Step after step, it presents nearly the same surface, the same angle, the same resistance. At first, this seems like an advantage. Predictability sounds efficient. It sounds like something a rational system would prefer. But biological systems are not purely about efficiency. They are about adaptability. When the environment stops changing, the need for adjustment decreases. Your muscles begin to operate in more repetitive patterns. Your nervous system receives less varied input. The range of micro-adjustments narrows. It's like playing the same note on a piano over and over again. Technically correct, but informationally poor. Now here's a thought experiment. Imagine learning to balance on a perfectly stable surface that never changes. You might become good at that specific condition. But the moment something shifts, a slope, a rock, a bit of movement, you would struggle. Now imagine the opposite. You practice balance on surfaces that are always slightly different. You never master a single condition perfectly, but you become flexible. You develop a system that can handle variation. Which one is more useful in the real world? Your body seems to prefer the second approach. And this leads to an interesting idea. Walking on dirt is not just about reducing impact or changing force, it is about maintaining a certain kind of conversation between your body and the environment. A conversation rich in variation. Concrete simplifies that conversation. It reduces the number of questions the ground asks your body. And when fewer questions are asked, fewer answers are required. Over time, that may change how your system behaves, not in an obvious, dramatic way, but in small, accumulating adjustments. But here is where honesty matters. We do not yet have a complete scientific map of how this loss of variability affects the human body over long periods. We can observe differences in muscle activity, in balance, in movement patterns, but connecting those observations to clear long-term outcomes is difficult. Because the body is always adapting. If you live on concrete, your body learns concrete. It builds patterns suited to that environment. Those patterns feel normal, even if they are narrower than what your body might be capable of. So the real question becomes harder. Not is dirt better than concrete, but what kind of system does each surface quietly train you to become? Now we arrive at something even less visible, but perhaps more important than force or surface structure. When you walk, you are not just moving, you are sensing. Your feet are filled with receptors that detect pressure, stretch, vibration, and subtle changes in texture. These signals travel through your nervous system to your brain, where they are combined with information from your eyes, your inner ear, and your muscles. All of this happens continuously without your awareness. You don't feel data, you feel something simple, like comfort or discomfort, stability or instability. But underneath that simplicity is a dense stream of information. Now consider what happens when the quality of that information changes. Dirt, grass, sand, these surfaces are irregular. They vary from step to step. One patch might be slightly softer, another slightly firmer. There may be tiny slopes, small shifts, unexpected textures. Each step produces a slightly different pattern of signals. Your brain receives this variation and uses it to refine your movement. It adjusts muscle activity, corrects posture, and updates your sense of balance. In a way, your body is constantly learning, even when you are just walking. Now compare that to concrete. Concrete is consistent, extremely consistent. The same flat surface step after step with minimal variation. The signals from your feet become repetitive. At first glance, that might seem beneficial. Clear, predictable input should be easier to process. But here is the subtle problem. Biological systems often rely on variation to stay sensitive. If a signal never changes, the system begins to ignore it. You can see this in other senses. When you first enter a room with a strong smell, you notice it immediately. But after a few minutes, the smell seems to fade. Not because it has disappeared, but because your sensory system has adapted. The same principle may apply, in a quieter way, to how your body processes touch and pressure from the ground. If every step produces nearly identical input, your nervous system may reduce its sensitivity to that input. It becomes background information, and when sensitivity decreases, subtle details are lost. Now, it is important to be careful here. We can observe that varied surfaces produce richer sensory input. We can measure differences in nerve activity and muscle response. But translating that into a complete understanding of long-term effects is still difficult. Does reduced variation lead to reduced coordination over time? Does it affect balance in meaningful ways? Does the body compensate so effectively that the difference becomes negligible? These are open questions. Because the nervous system is not passive. It adapts, reorganizes, and finds ways to function under many different conditions. Someone who spends most of their life on concrete does not become incapable of movement. Their system adjusts. It learns to operate efficiently within that environment. But efficiency is not the same as richness. A system can become very good at handling a narrow range of inputs, while losing some ability to respond to a wider range. And this brings us back to the idea of conversation. When you walk on dirt, the ground is constantly saying something slightly different to your body. The signals are varied, sometimes unpredictable, occasionally challenging. When you walk on concrete, the message is almost always the same. Over time, your nervous system may begin to treat that message as unimportant, not because it is useless, but because it carries little new information. So the question becomes more subtle than before. It is not just about how hard or soft a surface is. It is about how much information it gives you, and how much of that information your body continues to pay attention to. Now we reach a point where things become less comfortable, because the explanations start to blur. Up to this point, we've been talking about forces, energy, and sensory feedback, things we can at least attempt to describe using physics and biology. But there is another layer often brought into this discussion, and it is much harder to handle carefully. You may have heard the idea that walking barefoot on dirt somehow connects you to the earth in an electrical sense. That the ground contains a vast reservoir of charge, and by touching it, your body exchanges electrons in a way that affects your health. Now, from a strictly physical perspective, parts of this are true. The earth is electrically conductive. If you are standing barefoot on soil, especially if it is slightly moist, there can be a flow of charge between your body and the ground. Your body itself is an electrical system. Your nerves operate through electrical signals. Your cells maintain voltage differences across their membranes. So the idea that electrical interaction exists is not controversial. But here is where the difficulty begins. The existence of an effect is not the same as understanding its significance. Just because charges can move does not mean that movement has a meaningful impact on the complex systems inside your body. The scale matters. The pathways matter. The mechanisms matter. And this is where current scientific understanding becomes uncertain. There are studies that suggest possible effects of grounding on inflammation, sleep, or stress. There are also studies that find little or no consistent impact. The results are mixed, often small, and sometimes difficult to reproduce. This creates a gap, and humans are uncomfortable with gaps. When we encounter something we don't fully understand, we tend to fill in the missing pieces with stories that feel complete. We prefer a neat explanation, even if it goes beyond what the evidence supports. So one person might say, it's all about electrons flowing into the body. Another might dismiss the entire idea as nonsense. But both positions can be misleading, because the honest answer sits in a more uncertain place. Yes, there is electrical interaction between your body and the ground. No, we do not yet have strong, clear evidence that this interaction produces large, reliable, biological effects in the way it is often described. And this is not a failure of science. It is a reflection of how complex the human body is. Your body is not just an electrical system. It is also mechanical, chemical, and informational. These systems interact in ways that are not always easy to isolate. If something changes electrically, it might influence chemistry. If chemistry changes, it might influence how tissues respond to force. If that changes, it might alter how you move. But tracing that entire chain, from electrons in the ground to long-term health outcomes, is extraordinarily difficult. So we are left with a situation where we can describe some parts clearly, we can measure some effects, but we cannot yet connect all the pieces into a single, reliable explanation. And this is exactly the kind of situation where humans struggle the most. Because we like certainty, we like clean answers, but reality often refuses to provide them. So instead of asking, is grounding real or not, a more precise question would be, what role, if any, does electrical interaction with the ground play within the much larger system of forces, feedback, and adaptation we've been exploring? And the honest answer, at least for now, is we don't fully know.